Hi everyone, once again welcome back to our channel. Today going to discuss about the thermal properties of solids subtopics, the moduluses. Here shearing modulus and bulk modulus, isothermal bulk modulus of elasticity and adiabatic process, adiabatic modulus of elasticity. First of all, we were discussing about the going to modulus, shearing modulus or rigidity modulus or tangential modulus. What is the tangential modulus? What is the explain the now discuss about the shearing modulus or rigidity modulus or tangential modulus. Okay. Now first of all, statement the modulus of rigidity or shearing. Within the elastic limit, the ratio between shearing stress to shearing strain is called as here modulus of rigidity or shearing modulus or tangential modulus. Already ఇవి మనకు ఫస్ట్ క్లాస్లో డిస్కషన్ చేయడం జరిగింది. 4 మార్క్ క్వశ్చన్స్ ఐపీ టీఎస్ ఏపీ అన్నీ ఒక ట్రెసెస్ modulus and strains both are discussed about already first topic first class. Now briefly explanation modulus, shearing modulus. First of all, statement once again, the statement of the within the elastic limit, the ratio between shearing stress to shearing strain is called as here modulus of rigidity or modulus of tangential or modulus of shearing. First of all, statement is on here the ratio between here within the elastic limit, with in the elastic limit, the ratio between shearing stress to shearing strain, is called here modulus of rigidity, modulus of rigidity, modulus of model rigidity or a shearing modulus. Okay, shearing modulus. So it is denoted by capital G. It is denoted by here capital G. దేంతో చూపిస్తున్న దీన్ని capital G. So shearing stress is shearing modulus G is equal to shearing stress by shearing strain. Here shearing strain. Okay, strain. Now explain the with diagram statement here. Shearing modulus is equal to shearing stress by shearing strain. Here shearing stress means statement and shearing strain statement. First of all, with diagram here shearing stress statement, the restoring force acting per unit area of the cross section, the restoring force per unit area of the cross section acting parallel to that surface, that area of the cross section is called as here shearing stress. And now with diagram, ikkada diagram chudandi. For example, a cube of material, the base lower surface fixed, the lower surface here fixed. The tangential force applied on the upper surface of the cube, So the upper layer displaced some initial point to some place. Here, according to the diagram here, this is a, for example, this one cube. This is a cube. Now this is a here cube. Okay, this one here cube. Now here A is a upper surface of the cube, and this is a lower surface of the cube. This one here lower surface of the cube. So the force applied parallel to this surface. That surface. The lower surface fixed. Ante lower surface name chestunna fix chestunna. So lower surface here fixed. Okay. Fixed. Now this force applied to the tangential force. Sorry, this is a tangential force, that means parallel force applied on this area, this unit area. So now here this is a displace here initial this is the displace upper layer initial point to, for example, here this one A prime, this is for example B, this is B prime, this is fixed point here CD. Here CD is a fixed points, lower surface of the this is a cube. అంటే ఈ క్యూబ్ యొక్క అడుగు భాగాన్ని ఫిక్స్గా ఉంచి అప్పర్ తలం పైన మనము ప్యారలల్ ఫోర్స్ అప్లికేషన్ చేసినట్లయితే సంథింగ్ డిస్ప్లేస్ అవుతుంది. సో హియర్ దిస్ ఇస్ అ యాంగిల్, దిస్ వన్ హియర్ యాంగిల్ theta, ఫర్ ఎగ్జాంపుల్ దిస్ ఇస్ అ యాంగిల్ theta. Here the diagram simply here draw the here this one. Okay, here B, C and D. This DC is a fixed. Okay, now this is a area, the perpendicular distance here A, this one here B, A prime displaced here, B prime here displaced. The angle, this one here angle, this is the angle. This angle is called here shearing strain. The angle is here called here shearing strain. So shearing strain is equal to this, the perpendicular distance between this cube AC is equal to capital L, for example, the distance of the displacement of the this point here small x, small here, this is this one here L. So the shearing strain and shearing stress statements, this force, this is a force is a parallel force, that means a tangential, that force is acting parallel to the this upper surface of the cube. Okay, this here this upper lower surface is a fixed. Now statement of shearing stress, the restoring force per unit area of the cross section acting parallel to the that surface is called as here thermal shearing stress, here called as here shearing stress. So shearing stress is equal to the applied force parallel force by this surface. So shearing stress is equal to here shearing stress is equal to parallel force, here parallel force by area, parallel force by area. Okay, this is a shearing stress stress. Next, shearing strain. The shearing strain is equal to theta. Here theta is equal to statement shearing strain, the ratio between here the relative displacement, here this is the relative displacement between opposite surfaces and perpendicular distance between both surfaces, perpendicular distance between both surfaces. This is called as a shearing strain. Shearing strain. So shearing strain is equal to L by L, capital L by small l by capital L. Here small l means the relative displacement. The relative displacement between opposite surfaces, and capital L means the perpendicular distance between two surfaces, upper surface and lower surfaces. This is called as a shearing strain. Shearing strain is equal to small l by L capital L, that is equal to theta. So statement, note this one here. Note this one. Shearing stress or rigidity stress or tangential stress. Note this one. Statement రాసుకోండి. Stress, shearing stress statement. Concept of mains and JEE mains, NEET. మనకి ఇవి నీట్కి అండ్ మెయిన్స్కి కాన్సెప్ట్స్. ఓకే, షేరింగ్ స్ట్రెస్, shearing stress. Okay, statement, the ratio between the relative displacement between relative displacement between here these opposite surfaces, faces, just faces రాసుకోండి, faces and opposite surfaces and statement ఏంది, షేరింగ్ స్ట్రెస్. ఓకే, షేరింగ్ స్ట్రెయిన్ రాయండి స్టేట్మెంటు. షేరింగ్ స్ట్రెయిన్. ఓకే, ద రేషియో బిట్వీన్ relative displacement between opposite faces and perpendicular distance between both faces is called shearing strain. Okay, so shearing strain is equal to so theta that is equal to here L by L. Next statement, shearing stress. Okay, shearing stress, దీన్ని మనం ఏమంటున్నాం ఇక్కడ, rigidity stress or tangential stress. Okay, shearing stress. Okay, the restoring force per unit cross section of area of cross section, area of cross section acting parallel to that surface, that means here this surface, parallel to that surface is called here tangential or shearing or rigidity stress. Okay, rigidity, shearing stress. Okay, So shearing stress is equal to here tangential force means here, okay, tangential force, this is force here parallel to the surface, this force here parallel to the surface by area, by surface area, by area, that is equal to here parallel force by here area. This is a shearing stress, this one here shearing stress. In this process here, the due to unit restoring force or tangential force. In this process here, the shape is changes, but its volume remains unchanged. Its volume here remains unchanged. అంటే ఇక్కడ ఏంటంటే మనకి ఈ ఫోర్స్ అప్లికేషన్ చేసినట్టయితే షేప్ అనేది చేంజ్ అవుతుంది. ద షేప్ ఈస్ చేంజెస్ బట్ ద వాల్యూమ్ రిమైన్స్ కాన్స్టాంట్. దట్ మీన్స్ వాల్యూమ్ రిమైన్స్ అన్చేంజ్డ్. హియర్ దీస్ 2 పాయింట్స్ రాసుకోండి. నోట్ దిస్ వన్. ఇన్ దిస్ ప్రాసెస్ హియర్, ఇన్ దిస్ process volume, shape of the shape is changes. Here shape changes but here volume constant, volume remains unchanged. Here the shape of the cube changes. So this is the information of just for shearing rigidity or tangential rigidity. Next one, note this one here, note cheskundamma, just concept of NEET and mains. Okay, note this one. Next, bulk modulus. Here next here bulk modulus. The bulk modulus means, the bulk modulus defined as here the ratio between volume stress to volume strain is called as here bulk modulus. Now hydraulic modulus, bulk modulus and volumetric modulus. Okay, here bulk modulus, okay, this indicates here B, this is indicated here B. It is defined as the ratio between volume stress to volume strain is called as here bulk modulus, So statement, first of all, the ratio between, within the elastic limit, the ratio between bulk strain to bulk stress, bulk stress to here bulk strain, bulk stress to bulk strain is called here bulk modulus. Okay, so the bulk modulus is equal to B is equal to here B, bulk modulus B is equal to bulk stress by bulk strain, here bulk strain. So bulk stress by here bulk strain. Okay, that is equal to here minus delta P by here V, delta V by here V. This is a bulk modulus, that is equal to here, minus F by here V to A into delta V. This is a bulk modulus. Okay, this one here bulk modulus. Now first of all, when a sphere or metal or fluid compressed subjected to pressure, then the volume of the sphere or liquid decreases. The pressure is increased, the volume is here decreases. So in this process, now the volume is constant, the volume is here changes, but the shape is constant. Here in this process the shape is constant, అంటే starting ఏ shape లో ఉంటుందో తర్వాత కూడా అదే shape లో ఉంటుంది, but the volume is changes. First of all, big volume, after that the pressure acting on the spiral fluid, the volume is decreased or increased. Okay, this is so the negative symbol, negative sign indicates the pressure is increases with the volume is decreases. Now with diagram, first of all, the body placed in the cube, for example the cube placed in a fluid. Okay, now initially the cube of the sphere or sphere, this is a sphere, solid sphere. This solid sphere immersed in the fluid or placed into the fluid. So now initial volume here, this is the initial volume, okay, volume. After that, this after immersed, so this volume is decreased, this volume is here decreased. This is a final, this one here final volume. Okay, final volume V minus here delta V, V minus here, that means here V minus here delta V. This is change in volume, this is a change in volume. This one here original volume of the sphere. Now the force acting perpendicular to the here, the force acting perpendicular to the this surface of the sphere, surface of the here sphere. ఎలా ఉంది force ఇది perpendicular to the surface, perpendicular to the surface. Okay, perpendicular to the here surface. So statement stress, bulk stress, the restoring force per unit area or the normal force acting on the unit area, the normal force acting on the unit area of the body, this is called as here bulk stress. Bulk stress, bulk strain means the ratio between change in volume to original volume of the given sphere or fluid. This is here called here bulk strain. Okay, first of all, here change in volume, this one V minus delta V, original volume or initial volume here V. So the force here, this force here acting perpendicular to the surface of the this sphere, perpendicular to surface of the this sphere. Now this area, this one here surface area, this applied force. So here pressure is equal to force by area, force by area. This is here delta P means volume stress. Here delta P means here volume stress. Okay, now note this one, volume stress is equal to here volume stress is equal to here force by area. Here this area means surface area, this one applied force or compressing force. So volume stress is equal to here force by area, that is equal to delta P minus here delta P. This is a change in pressure. Now the pressure is increases, the volume is here decrease. అంటే ప్రెజర్ పెంచినట్టయితే దాని యొక్క వాల్యూమ్ ఏమవుతుందమ్మా డిక్రీజ్ అవుతుంది. నౌ హియర్ వాల్యూమ్ స్ట్రెస్, వాల్యూమ్ స్ట్రెయిన్, here వాల్యూమ్ strain is equal to here change in volume by original volume. Here change in volume means here this is a here change in delta V means here change in volume. So delta V by V, change in volume to here original volume. This is called here volume strain. The ratio between change in volume to original volume is called as here volume strain. The volume strain stress means the force per unit area. This force acting perpendicular to the surface of the body, This is so bulk modulus is equal to here volume stress by volume strain, that is equal to delta P by delta V by V, that is equal to minus FVA delta V, that is equal to B. Here minus symbol, negative symbol indicates the pressure is increases with the volume is decreases. Okay, now note this one. Next one, in this process here, volume is constant, sorry, volume is changes. Here the shape of the body changes, the shape of the body changes. So note రాసుకోండి, ఈ పాయింట్ రాసుకోండి ఇక్కడ. In this process here, in this process here, shape of the body same, the shape of the body here ఏం రాద్దాం అంటే remains unchanged రాద్దాం. ఓకే, the shape of the body remains unchanged, but here but the volume is changes, the volume is changes, the volume is here changes. These key points, these are here key points. Now the bulk modulus of the fluids applicable to fluids, liquids and gases. So the bulk modulus applicable to fluids and solids and gases. No, note this one point రాసుకోండి. The bulk modulus of three states here. Now bulk modulus here solids greater than, right? Bulk modulus here liquid greater than, and here bulk modulus, okay, bulk modulus here gases. This is the main point. Note this one. Next one, the isothermal, note this one. Isothermal bulk modulus of elasticity, isothermal bulk modulus of elasticity. Now here isothermal process and adiabatic process. So isothermal bulk modulus, isothermal here bulk modulus of elasticity, adiabatic bulk modulus of elasticity. So the relation between two process, adiabatic and isothermal. So first of all, the isothermal bulk modulus of elasticity is the bulk modulus of a gas, the bulk modulus of a gas in isothermal condition is defined as here isothermal bulk modulus of elasticity. Now first of all, here isothermal bulk modulus of elasticity as elasticity delta E theta. Now first of all, here statement, the bulk modulus of a gas, in isothermal condition is defined as here isothermal bulk modulus of elasticity. It is indicates here E theta. Now we know that the isothermal process PV is equal to constant. Here constant. Now according to we know that here PV is equal to constant. Here P means pressure, V means volume of the gas. This equation differentiating on both sides, partial differentiation on both sides. After we will get some equation. Now this equation differentiating differentiating both sides here PV P that is equal to once dV plus here V dP is equal to constant. This equation differentiating both sides, now P dV plus V dP is equal to 0. Now here simplifies P dV is equal to this taken right side minus V dP. Now here dV by V is equal to minus here minus dP by here dP by P, but here dP by P, here P is equal to simplifies this is a pressure, this is a change in pressure, dP means change in pressure, V means pressure, just pressure, change in volume, this one here volume here. Now first of all E theta is equal to minus here dP by delta V by V. This is a isothermal modulus of elasticity. Isothermal modulus of elasticity. E theta is equal to minus dP by delta V by V. This is a isothermal modulus of elasticity. Now this process dP, just P is equal to here P is equal to simplifies P is equal to pressure is equal to remaining here minus delta P by delta V by V, delta here V by V. This indicates here isothermal modulus of elasticity of the gas. So that is equal to here simplifies here P is equal to this is equal to now E theta. That means the isothermal modulus of a gas is equal to the pressure of the gas. అంటే ఈ modulus of the elasticity దేనికి ఈక్వల్ టు ఉంది, జస్ట్ ప్రెజర్ కి ఈక్వల్ గా ఉంటుంది. సో నౌ హియర్ the isothermal point here, the isothermal modulus of elasticity is equal to here is equal to pressure of the gas. Here just is equal to pressure is equal to here pressure. This is a key point. This one here key point. Okay, this one gases. This gases no. This one. Next one adiabatic process. Next one here adiabatic process. Note this one. First of all, note this one. Adiabatic process. So finally, this is the main point. This pressure is equal to isothermal modulus of elasticity. Okay, here del E theta. Now next adiabatic process. Now adiabatic process, the adiabatic modulus of elasticity. Now adiabatic modulus of elasticity ఈ పై ఇందాక రాసింది ఏదమ్మా జస్ట్ టీటా జస్ట్ ఇయర్ పై. నౌ ద modulus of a gas in adiabatic condition is defined as here adiabatic modulus of elasticity. Now here according to we know that here adiabatic process. So adiabatic process here, adiabatic process, adiabatic condition, adiabatic process. Okay, here P V power of gamma is equal to here constant. Okay, constant. PV power of gamma is equal to constant. Here molar, the ratio of molar ratio of the molar specific heats. Gamma means here the ratio of molar specific heats. Here V means volume of the gas, P here pressure. This equation differentiating on both sides. So on after we will get here the adiabatic modulus of elasticity. Now here this one differentiating both sides, okay, both sides. Now here first of all P is constant, after we this one, so P constant here, gamma V power gamma minus 1 and dV place next V power of gamma is constant here dP, that is equal to here 0, that is equal to 0. Now this integration part P is constant, this differentiating చేసి ఇక్కడ మనకి ఏం చేస్తుందంటే ఈ టర్మ్ వస్తుంది ప్లస్ now after this is constant here dP, here dP by here P into gamma V power of gamma minus 1 here dV is equal to minus this taken right side minus here V power of gamma dP, V power of gamma and dP. Now this is a simplies dP by P is equal to, this is a dP by P is equal to, okay, one step here, this is a right here, this one we want just P, we want just here P, so P is equal to this equation minus V power of gamma dP by this terms gamma here V power of gamma minus 1 and dV and here dV. So this is a taken upper పైకి తీసుకుపోతే ఏమొస్తుంది, just simplifies here P is equal to this one, okay, gamma P is equal to minus V power of gamma and V power of minus gamma minus 1, this one taken denominator taken numerator as a the కింద ఉన్నదాన్ని పైకి తీసుకెళ్ళిపోతుంది ఈ టర్మ్స్ వస్తుంది మనకి, జస్ట్ రిమైనింగ్ ఇయర్ dP, here dP means change in pressure. Now simplies the bases are here equal, same volume is a, base is a same, so the powers are additions. Now here V power of minus gamma plus minus into plus minus gamma minus into minus plus, okay, remaining here dP, so gamma get cancelled, gamma get cancelled, simplies here P minus V remaining power V power of 1, that is equal to V, so V and dP, so is equal to here remaining terms by dV, by here by dV, okay, by dV, by here dV, simplies P gamma is equal to gamma P is equal to here gamma P is equal to minus dP by dV by here V, dV by here. This is a volume strain, this one here volume stress, that is equal to bulk modulus, that is equal to here bulk modulus. So bulk modulus is equal to gamma P, bulk modulus is equal to here gamma p. But here bulk modulus means that nothing but here adiabatic modulus of elasticity. Adiabatic modulus of elasticity. This is the here E pi. This is equal to here E pi. Now simplifies gamma p is equal to, this is equal to here E pi. This is equal to E pi. Now here E pi is equal to minus dp by dv by here v. This is a adiabatic modulus of elasticity. E pi is equal to minus dp by dv by v, that is equal to here. Here this equation indicates here represents, so the adiabatic modulus of elasticity is equal to mu gamma times of, this is a gamma times of pressure, gamma times of pressure. So here point రాసుకోండి, here modulus of adiabatic modulus of elasticity is equal to mu times gamma times here gamma times of pressure, gamma times of here pressure, gamma times of pressure. So therefore E pi is equal to gamma into p, gamma into here p. This is a modulus of adiabatic modulus of elasticity is equal to gamma times of pressures. Now the ratio between, this is a next one continuation. So this is equation 1, first equation isothermal and adiabatic process. Note this one here. Next one, the ratio between adiabatic modulus of elasticity to the isothermal modulus of elasticity. Next, the ratio between, notice one, the ratio between adiabatic modulus of elasticity E pi to the adiabatic, the isothermal modulus of elasticity in E theta. So that is equal to here E pi by E theta. So E pi nothing but here gamma times of pressure by here just pressure. This is equal to isothermal modulus of elasticity is equal to just pressure. Now the adiabatic modulus of elasticity is equal to gamma times of pressure. So pressure get cancelled, simplifies here E pi by here E theta is equal to here gamma. This is the relation between adiabatic modulus of elasticity and isothermal modulus of elasticity. Next one, okay, next class, the continuation, density, compressibility and Poisson ratio, the ratio between lateral strain, the ratio between lateral strain to Poisson ratio. After class we will discuss that points. Now నెక్స్ట్ మన ఛానల్ వాచ్ చేయండి, చూడండి, ఫ్రెండ్స్తో షేర్ చేసుకోండి. ఆల్ ది బెస్ట్ ఫ్రెండ్స్, థ్యాంక్ యూ.